Welcome everyone. Excited to have you join for the PyTorch Partner Collaborations talk. My name is Geeta Chauhan and I lead the PyTorch Partner Engineering at Facebook. We will look at partner integrations and dive deeper into the profiling models, scaling AI in production, ML ops with Kubeflow pipelines, and ML flow. PyTorch ecosystem is rapidly growing and we put great emphasis on PyTorch as a platform with a wide range of ecosystem partner integrations built on top. These range from libraries like Hugging Face, OpenMind, to all the cloud provider integration and newer solutions like the MLOps platform integrations. Next, we will dive deeper into few of these. For profiling models, we collaborated with Microsoft for the new PyTorch Profiler with TensorBoard Profiler plugin. We open sourced Facebook's internal tools for GPU monitoring as the Kineto library, which is built on top of cupd, and Microsoft contributed the Profiler plugin for TensorBoard along with VS Code integrations. Now one can see both the GPU and PyTorch level traces in a single view with actionable recommendations. It is a simple pip install for the Profiler plugin and comes with views for timeline tracing, high-level overview with recommendations, operators, and kernel views. Just call the import torch profiler and then set the context and pass parameters like GPU, CPU activity tracing, record tensor shapes, and then in the training loop, call the profiler.step for the traces. In the timeline traces view, one can see all the CPU threads and the GPU streams and see all the PyTorch 8 ops and the CUDA kernels and user annotated record functions. One can see the flow of events from CPU to GPU and identify bottlenecks. You can inspect stats for individual activities. In this example, NVIDIA SMI shows 86% utilization. However, only a small fraction of the streaming multiprocessor on GPU are actually used. After we increase the input size, the WOPS per SM utilization looks much better. Here is an example of call stack for the PyTorch Lightning integration. All you have to do is launch the Lightning training with --profiler flag set to PyTorch and it automatically generates all the traces. Let's look at the overview of the profiler. You see here that we ran the test on a single GPU machine with one worker. You can see the execution time breakdown and the step time breakdown. And in the recommendation section, you can see the run is taking long for the input data loading with 20.8% of step time at data loading. It is telling us to set the number of workers on data loaders and enable multiple processing. Let's look into the actual code. You see here it's a simple CFAR 10 model and we are loading the data with default number of workers. And then we set up the profiler context and we do the zero grad backward and then do the actual optimization. So let's increase the number of workers to 10 now and see what difference does it have on the profiling. So we run the profiler step again and we can then see the output and see what is the difference. In meantime, let's look at the operator view. So you see here all the operators, top 10 operators are shown. In the GPU kernel view, we can see the top GPU kernels, you see the cuDNN kernels, call time, duration, etc. Now the second run completed and we see that the extra time for data loading is gone and the time has reduced to 125 milliseconds. Let's look at the trace view as well. So in the trace view, you can see the profiler steps, the different steps that ran. You can select a bunch of kernels and see the details in the section below. You can select the GPU kernels and see all the details, the cuDNN kernels that are getting called. You can pan and zoom, go into the details of a specific profiler step and see all the optimization and other steps over there. So here we have the details of the GPU traces, and if you select a particular kernel and click on the launch for it, you can see how the flow is going from the CPU to the GPU. Now let's look at the tensor board in the VS Code. So we launch the tensor board command, and you can see here that the tensor board is loading inside VS Code. And you can see all the same views, the overview, operator, kernel, etc. You can move around, see all the details. So the 2 steps that we had run with and without the optimization, all those are visible here. So this is with the optimization, and this is the previous step that we ran. You can also see the trace view inside VS Code. So here the traces are loading. You see all the steps, the profiler steps. You see the CPU streams at the top and the CUDA stream at the bottom. There are 2 CPU streams and 1 CUDA stream, and you can dive and see that the profiler step has the optimizer step SGD. You can dive in, see the details. It takes 260.025 milliseconds. You can select a set of GPU kernels and see the details of those. For the scaling AI in production, in partnership with AWS, we launched TorchServe for model serving last year. It provides a scalable solution with model management, inference, and matrix API. It comes with default handlers for all the common ML tasks like image segmentation, text classification. One can write own custom handlers. It supports model versioning with rollbacks. And now one can do autoscaling with Canary rollouts and monitor using Prometheus and Grafana. We added support for a range of integrations, the Kubeflow KF serving with Canary rollouts, MLflow integration, Captum for model interpretability, AI accelerator support for AWS Inferentia, support for Kubernetes and all major cloud, the AWS, Azure, and GCP. A wide range of deployment models are supported across the different clouds and on-prem based on your needs. For the ML ops with the Kubeflow pipelines, in partnership with Google, we are currently working to integrate PyTorch into Kubeflow pipelines for model training with hyperparameter optimizations, visualizations in TensorBoard, Captum interpretability. We already launched the standalone integration of model serving with KF serving 0.5 release. This is what the full pipeline will look like, and we will provide sample workflows for computer vision and NLP use cases. So you will start by identifying the problem, collect all the data for analysis, choose the ML model and code your model, and then you will run the experiments in the Kubeflow pipelines using your PyTorch model training and do the hyperparameter optimization using Axe and PyTorch. And then in the production phase, you will start with the transformation of the data where the PyTorch data loaders and the preprocessors will be used, followed by the training of the model, and then the packaging and deployment of the model on TorchServe KF serving. And for model monitoring and the performance tracking, you will take a look at PyTorch Profiler, Captum, Prometheus, and Grafana. The KF serving integration with TorchServe was launched back in Feb as part of the 0.5 release, and we are now working with Kubeflow pipelines. So let's look into a demo. So what you see here is a simple example of Kubeflow pipeline deployment. So this is a Jupyter notebook where we are doing the pipeline deployment. So we are connecting to the cluster here, giving the authentication details. So then we are calling the actual experiment, specifying the deployment task, and this is what the Kubeflow pipeline looks like. So this is for the BERT model. Then the pipeline is processing. So here the PVC was created, the model was downloaded, packaged, and it was deployed. And you can run the prediction and get the inference results. So for the MLOps with MLflow, in partnership with Databricks, we had launched the first phase of integration of MLflow with PyTorch last year with support for automatic metric logging for PyTorch models. We had added ML model integration with the examples for Hugging Face BERT and many more. For the model registry, we added support for saving the artifacts and also the ability to save and load Torch scripted models. And we had built the TorchServe MLflow deployment plugin for serving PyTorch models from MLflow itself. Now we are adding new features for support for CAPTM for model interpretability, support for model signature verification, and hyperparameter optimization using Axe and PyTorch. So the code that you see here at the top is for CAPTM integration, and you see the visualization at the bottom. And then the code at the bottom right is for the model signature. So this, if you want to do signature verification when your model predictions are being run, you can do that now with MLflow. And this here is what the code example looks like for hyperparameter optimization integration with Axe and PyTorch for best parameter search. Thank you all for listening. Please reach out to us on GitHub. Do contributions. We are looking forward to doing active engagements with you. Thank you all very much.